Have you ever wondered why you've never seen melted salt? Have you ever wondered why water is a liquid at room temperature? It has to do with their bonds. Remember, we've already studied ionic compounds and the properties associated with ionic compounds, and that they have very high boiling points like salt, NaCl, sodium chloride. And now we're moving on and we're going to study compounds that are molecular and that generally have lower boiling points because it has to do with a sharing of electrons rather than a transfer of electrons. In this lesson, you should be able to understand that a single covalent bond represents one shared electron pair. Remember, co, like cooperate, co means together, or cooperate. The atoms are cooperating, they're sharing an electron pair. And then what we're going to do is we're going to learn to draw Lewis dot structures for covalently bonded compounds. Before we start, though, let's look at the vocabulary. A covalent bond, we just said, is a bond in which electron pairs are shared. So they're shared electron pairs. Don't forget about these prefixes. Co means together or with, to share, like cooperate. A single bond is one pair of shared electrons. A double bond is two pairs of shared electrons. A triple bond is three pairs of shared electrons. If you have three pairs of shared electrons all together, the two atoms, the triple bond, is sharing 6 total electrons. And we'll see what that looks like in a few minutes. Multiple bonds just refers to double or triple bonds. That's a vocabulary word that the Regents likes to use. So multiple bonds refers to an actual double or triple bond, not a single bond. Double or triple bonds. And a molecular compound, remember MoCo, Model Congress thinks it means Model Congress, but we know it stands for molecular compounds have covalent bonds. Molecular compounds equals covalent bonding. So now we're ready to get started. The first thing we need to know is what the big idea is. The big idea of this lesson is that molecular compounds consist of atoms. Molecular compounds consists of atoms that share electrons. Electron pairs to form molecules. And we're going to be able to model this sharing of electrons using electron dot diagrams. Let's see what this looks like. Okay, the first thing I want to do is we know that we're eventually going to draw electron dot diagrams for covalent compounds, but let's start with what we already know. We've already drawn electron dot diagrams for ionic compounds. So you can see that this first formula unit is held together by oppositely charged particles. That means you have two ions or charged particles, so this is an ionic compound. Notice the difference here with water. Water is a covalent compound. There are no charged particles or ions. The chemical formula, notice there's one magnesium and two fluorine ions or fluoride ions. Remember, you change the ending. Here we have two hydrogens and one oxygen. We can count the atoms in the same way to write the formulas. To name the formula here, we have magnesium, we name the cation, and then we name the anion, changing the ending to IDE. Here we use prefixes. Remember, we take the first element and we look and we see there are two atoms, so we call that dihydrogen. The second element, there's only one atom, we call it monoxide. Dihydrogen monoxide, more commonly known as water. And if you look, as we said, here in this diagram we have charged particles or ions. And here, if you notice, there's shared electron pairs. Okay, so how do we go about drawing these Lewis dot diagrams for molecular compounds? Well, there are three main rules that you have to keep in mind. A covalent bond represents one pair of shared electrons between two atoms. A pair of electrons is just two electrons. What you're going to do is you are going to draw the Lewis dot structures for each of the atoms involved, and you're going to see how many unpaired electrons there are from each atom. What you'll do is you'll circle the unpaired electron from one atom and an unpaired electron from the other atom to create a shared pair. You'll continue to pair all the unshared electrons until each atom has, you guessed it, 8 valence electrons around it. Unless it's hydrogen. Hydrogen would only have 2 valence electrons around it because hydrogen can't have more than 2 valence electrons. Let's practice. Okay, first thing, hydrogen fluoride. So we start by drawing the electron dot diagrams for each atom. We look up hydrogen. Hydrogen has 1 valence electron. Fluorine has 7. So we draw the electrons around it. I try and draw it so that the unpaired electrons are facing the other atom. It just makes it a little bit easier. Then I look. Fluorine has 3 paired and 1 unpaired. Hydrogen has 1 unpaired. If I take the 1 unpaired electron from each atom and circle it, now hydrogen would be stable because it has 1 shared pair of electrons around it, or 2. And fluorine has a stable octet, 2, 4, 6, and the pair makes 8. You try it. Turn off the tape and try it for fluorine. Okay, now keep in mind that fluorine exists as a diatomic. So you have 2 fluorine atoms bonded together. Each one has 7 valence electrons. So we look to see how many unpaired valence electrons there are and circle the one from each atom. And then we count 2, 4, 6, 8, including the shared around this fluorine, and 2, 4, 6, 8, including the shared pair around the other fluorine. Both now obey the octet rule. Let's try nitrogen. Practice 2. This is guided practice. So we take nitrogen. We know that nitrogen has 5 valence electrons around it. 1, 2, 3, 4, 5. Now remember, the unpaired ones I'm going to try and draw so that they're facing towards the other atom. Then I'm going to start to pair unpaired electrons. Well, here's an unpaired electron from each atom. Here's an unpaired electron from each atom. And here's an unpaired electron from each atom. So let's look at what this looks like now. We have nitrogen. It has 1 pair of electrons. And this nitrogen has 1 pair of electrons. And it has 3 pairs between it. Do you see that? So each nitrogen has 2, 4, 6, 8 pairs of electrons around it, either shared or unshared. The second nitrogen, 2 and 3 shared paired. That's 6. 2, 4, 6, 8. So if you look at nitrogen now, you'll notice that there's not only one bond shared between the two atoms. There are three bonds shared between the two atoms. That makes this nitrogen N2. This has a triple bond. That means it shares three pairs of electrons for a total of, or 6 electrons total. Okay? Try it with carbon dioxide. This is the toughest one yet because carbon dioxide, notice the di. So you have 2 oxygens. I'm going to put the carbon, which is the least electronegative element, in the middle, and 1 oxygen on each side. I have carbon has 4 valence electrons around it. 1, 2, 3, 4. Oxygen has 6. So I draw 6 valence electrons around each of the oxygens. Okay, then I start to pair electrons. I have 1 unpaired from the oxygen and 1 unpaired from the carbon here, and 1 unpaired from the carbon and 1 unpaired from the oxygen here. That means I have 2, 4, and 2 shared pairs, 6, 8 around the oxygen. Now I have 2, 4, 5, 6 around the carbon. I'm not done yet. And 2, 4, 5, 6 valence electrons around the oxygen. I have to continue to pair. So I pair 1 set, and then I have 1 set left of unpaired electrons. Now if I look around the carbon, I have 2, 4, 6, 8 8 shared electrons, 4 shared pairs. And around oxygen, I have 2, 4, 6, 8 electrons and 2 shared pairs. So turn off the tape and see if you can do it yourself. When you turn it back on, you'll see the answers. Hydrogen bromide is HBr. The Lewis dot structure, you have 1 valence electron around the hydrogen. You have 7 around the bromine. You have 1 unpaired electron around each. Circle them. That would be a single bond. If we were to redraw it, HBr, and you would notice that hydrogen now has 2 electrons around it, 1 shared pair, and bromine has 2, 4, 6, 8 total electrons satisfying the octet rule. If you do bromine, don't get tricked. Bromine is a diatomic, Br2. So you need to draw both bromines, each having 7 valence electrons. Notice that on each atom you have 1 unshared pair. Connect them. That would leave you with 1 single bond between the bromine atoms. Okay, phosphorus trichloride. Phosphorus trichloride is PCl3. This one's a little tricky. I'm going to draw it down here so I have more room. You have the P in the middle, the least electronegative, and the 3 chlorines around it. Now, the P has 5 valence electrons. Okay, I'm going to leave the unpaired electrons facing the other atoms, and each of the chlorines has 7. Circle the unpaired electrons. Now, here's the tricky part. This molecule consists of 3 separate single bonds. Do you see the difference between single bonds? Is 1 single bond between the atom of phosphorus and chlorine. Whereas nitrogen over here on the other page, let's go back, nitrogen has a triple bond because there's 3 bonds between 2 atoms. Be very careful. These are all single bonds. They are not multiple bonds. The last example is oxygen. Oxygen, remember, is a diatomic again, so it's O2. We have oxygen, has 6 valence electrons around it. The other oxygen has 6 valence electrons around it. What do you notice? How many bonds is it going to form? If you said that there are 2 shared pairs of electrons between the atoms of oxygen forming a double bond, then you are absolutely right. Oh, I forgot to draw the valence electrons around these guys. Technically, you would want them. Okay, good job. So if we were to compare and contrast the bonding in bromine and oxygen, remember bromine had 1 single bond between the atoms, whereas oxygen has a double bond between the atoms. Does phosphorus trichloride contain single bonds or triple bonds? The answer is a single bond. Remember, the reason is because there is only 1 bond between 2 atoms. You happen to have 3 different atoms sharing, you happen to have 3 atoms of chlorine, right? You have 3 atoms of chlorine bonded to the phosphorus, but each atom of chlorine is bonded with only a single bond. Don't forget to include the paired electrons that are not shared around your model. Okay, I look forward to seeing you tomorrow in class. Cheers.